good everybody. Good evening, everybody, and welcome to another show. It's been a while. It's been a while since we've done the roundtable format, but today we have Toady. Toady, are you there?
Yep, I'm here, Ranty. Good evening.
Good evening. Good evening. Nice to have you. Now, can you just tell us a quick rundown of this presentation that you have?
Yeah, sure. What this is, this came really from a couple of interactions, mainly with Spurs, but a little bit also with Right the Hand. I was very keen to show Spurs some things, but I was going away on holiday and I had to buy a barometer as well to show him these experiments relating to pressure, air pressure, atmospheric pressure, and temperature. So I went away, put this video together. Some other people then got involved. Got a little bit more complicated. There's a little bit of sort of theory in there as well. But it's about 20 minutes. There's theory, and then there's a video that shows me actually doing the experiment, which is, I think, reasonably conclusive. And it summarises some points that were made by Spurs and Right the Hand, and then I summarise what I think I have shown in the video. So hopefully it'll be enjoyable for some people, and certainly I'm sure Spurs will come back with guns a-blazing. Not that I'm trying to reignite the whole pressure debate, but you know, it's been an interesting and enjoyable debate, and I'm sure we'll go on for a little bit longer. Back to you.
Good stuff, good stuff. So essentially, mainly Spurskimo, a little bit to Right the Hand, and just a few hellos to the people in chat. We have currently 40 people watching, which is excellent. Anyway, without further ado, we will get this presentation on the go.
Okay, welcome to this video. This is a debate around pressure and barometers between me, Toady, who is reasonably well known now on the scene, and this character here, who we believe to be Spurskimo. I'm responding to challenges from Spurs on a number of hangouts and debates. This relates to pressure and its practical demonstration. Okay, the claims that have been made by Spurskimo and Right the Hand. Let's go through them just to recap what they've said on a number of hangouts and in a number of forums. First of all, that there is no such thing as atmospheric pressure, or indeed, Right the Hand also says it's inconsequential. Secondly, the so-called effects of atmospheric pressure are actually due to temperature. Thirdly, altering pressure will increase or decrease, depending which hangout it is, the temperature. Fourthly, pressure is linked to the water that is in the air or other gas and liquid, which doesn't seem to make much sense, but it is indeed what they have said. And then finally, that barometers cannot work at low temperatures because the metals freeze. When asked about the metals, Spurs just said that they were standard metals. So moving on, we're under pressure now, I think, in our community to respond to this. What are we going to do? We're going to recap on a few of the basic concepts around pressure and indeed how it works. Much of that material actually has been extracted from standard high school physics books, my son's physics book in fact, to help set the standard context. The interesting thing when I've looked at those physics books or notes is that they do contain an amount of maths and some formulas, but actually, unlike the argument from a lot of the flat earthers and from Spurs himself that we just learn parroting things and it's just learned by rote, in fact there's a number of questions there that makes the student question what the relationship is and what the phenomenon is and what the cause and effect indeed is. So there certainly isn't any rote learning there, and it's a shame maybe that Right the Hand and Spurskimo don't go back and do a basic physics course. I think it would improve their understanding significantly. The notes will cover the history of atmospheric pressure, how we define pressure, how we measure pressure, the difference between gauge and atmospheric pressure, which is often misunderstood and it's an easy mistake to make, and we'll touch on that, the various types of barometers that there are, and indeed the Aneroid barometer in detail, and this here is an Aneroid barometer, and I bought one that's virtually identical. And then finally, we'll show a video which includes an experimental one. Now, I need to thank a few people for helping me to put this presentation, this video together. That is the Rumpus, George Hanetiuk, Farmer's Boy, Brian, and indeed Dean or Stingray. All of them helped me assemble this material. and I'm very thankful for their help. It was a community effort. Okay, let's dive straight into it. What is atmospheric pressure? Well, air pressure is measured in newtons per meter squared, Pascal, or pounds per inch, which we're much more familiar with. That's the old PSI. Now, essentially, we're surrounded by an ocean of air. And so air pressure really is the amount of air that is above us that's pushing down onto us or into the surface that we're measuring against. So the pressure at the surface of the Earth is not something that's arbitrary. It's not an arbitrary measure on a scale that someone has just randomly invented. It actually is what we term as 1 atmosphere, and it amounts to a pretty consistent measure of the amount of air pressure at the point of sea level at certain normalized temperatures. Now that happens to be 14.696 psi, as we can see stated here, often called 14.7 psi. That's either 1 atmosphere as well, or indeed it's 101.325 kilopascals, as we can see here. Just to put all of that in context, because I think we probably need to, dry air, so that's dry air, not wet air, but dry air, because obviously wet air can vary a lot, but dry air has a density of 1.2 kilograms per meter cubed. So if you imagine you could take a meter cubed of air and you could weigh that, it would weigh about 1 kilogram. So, you know, it's a quite significant weight. We think of air as quite insubstantial. It's not. Okay, moving on. We see here a really nice picture, and I included it. It's from Douglas Seeger's Introduction to Ocean Sciences. There's a call out here at the bottom of where it came from. And we see this really nice picture actually of the troposphere, ozone layers, all the way up to the stratosphere and the mesosphere, which really shows the whole of our atmosphere. We can see where the jets tend to fly at about sort of 13, 14 kilometers up. And we can also see this line here, the red one, and this line here, the purple one. Now the purple one is pressure, and the red one is temperature. And the beauty of seeing this is we can see that there's a relationship between both of them, and we can see indeed that as temperature drops, there's also a change in pressure, so we can see that the two are indeed related. But we can also see that there is clearly not a one-to-one relationship between the two. You know, when Spurs says that pressure is temperature and temperature is pressure, we can clearly see that that is not the case from these typical measurements that we see here on this view. Okay, and you can also see obviously the sheer amount of air that is above us. If we are down here, you know, on the surface of the globe, we can see that there's a huge amount of air up above us. You know, up to what, 60 kilometers worth of air. Obviously getting thinner, but up to 60 kilometers worth of air. All right, let's move on to the measurement gauges and the barometer. So this we see here is a mercury barometer. This was developed by Torricelli, and we'll touch on him a little bit later. And he did this to measure atmospheric pressure. In fact, he was actually trying to solve a problem to do with pumps in the area that he lived in Italy. They were making these pumps, and they couldn't actually get water to pump above, I think it was about 34 feet, something like that, maybe 34, 39 feet. They had this problem. They make these pumps. They couldn't pump water above that height, and they called on Torricelli to have a look at it, and he came up with a barometer. Now, the height of the column of mercury is such that the pressure in the tube at the surface level is 1 atmosphere. So the beauty we have here is we have a tube. We put mercury into the bath below. The mercury goes into the tube, and the weight of the atmosphere that is above the bearing, the surface area here, where it is open within this bucket or container, pushes against it, and it pushes the mercury up to a height, in this case, of 76 centimeters. Now, this is mercury. Obviously, the heights will vary, and we'll touch on that if you used water or oil or other substances. I think there's a thing called the shark oil tube, which is one which is even less dense, I think, than water from memory, and is a very exciting thing that you can see somewhere in America. So, you know, different substances, different liquids can be used for making this, and they will all vary depending on the density of the substance used. Now, because this is 76 centimeters, or much better, 760 millimeters, pressure is often quoted in millimeters, but you can also do inches of mercury. So moving on, let's look closely at this barometer. So barometers measure atmospheric pressure. I mean, that's obvious. One type of barometer, the one that we're showing here, uses this column of liquid, and it's mounted in a reservoir which is open to the atmosphere, as I described earlier. The pressure exerted by the column is given by this formula, and we'll come back to this formula. It's a very important one. Pressure, absolute in this case, equals H times rho times g. Now, what are these? Rho is the density of the liquid that you're using. G is acceleration due to gravity, which we already know is 9.81 meters per second squared. And h is the resulting height of the fluid above the reservoir. And so we can use this in different formulations of this, this formula to work out different things. So if we know the density of a liquid, let's say it was water, and if we know the atmospheric pressure, and if we also know what the density of that liquid is, we can actually work out what height we would need for our barometer. And indeed, we'll see a touch on that in a sec. So atmospheric pressure is equal to 1.013 10 to the 5 newtons per meter squared. Now, for a mercury column, that is, as we said before, 760 millimeters in height. Yeah, so that's very convenient because mercury is a nice dense liquid, so we don't need a lot of it. So we can make a barometer that is less than a meter high because we don't want sort of 50-meter barometers. And we will touch on this later when we come to the water column. That's much less dense than mercury, so therefore the column that we make to be able to measure just 1 atmosphere is much, much higher. So here we see exactly what I've been just talking about there. This is Torricelli's original barometer, and you can see it's massive. It goes right out the side of this house. They've built some kind of structure and framework. There's a guy in the window pointing at it. It's all quite exciting, and he's doing this experiment in the market square. It took him a long time to blow that glass to get it straight, and all sorts of things to seal it off at the top. But really here he's doing the experiment, and here he is proving the fact that if you use water, which is of course less dense than mercury, you're going to need a very, very tall column. And indeed, at normal atmosphere, and at normal temperatures, so 1 atmosphere, normalized temperatures, we are not able to push this column above, I think it's about 30 odd feet, and we'll come to the exact measurement shortly. So, barometric pressure ranges, let's look at them. So typically it's 28 to 32 inches of mercury. I prefer obviously the imperial system because us in Europe we use that a lot. So 711 millimeters to 813 millimeters of Hg, and indeed you'll see that on the Aneroid barometer later, or 13.75 psi to 15.72 psi, and that is standard atmospheric pressure, and it ranges between these two values depending whether it's low pressure or high pressure, what the weather systems are doing across the surface of the Earth. Now, if we use water, which is what I spoke about earlier, instead of mercury, we have this formula. So the pressure is equal to 1 atmosphere. We're assuming this is a normalized standard atmospheric pressure. And then we have our G times H times rho. Now, as I said, rho is the density of indeed water, which we put into the equation here. G is 9.8 meters per second because of gravity. And of course, we want to calculate the height. So we move the height to the side, move the P over here, which is why we're dividing by it. So we divide all that through, we get to, I think what I said was about 34 feet, so 33.9 feet high. And indeed, that was the height of Torricelli's column. Very, very high. And then finally at the bottom, we've just got the standard here. We've got 1 atmosphere is equal to 760 millimeters of mercury, 29.9 inches of mercury, 101.355 kilopascals, or indeed 14.696 psi. And all of those are the same. So let's move on to pressure gauges. So an open tube manometer is a type of pressure gauge. One end of it is open to the atmosphere and the other end is subjected to whatever we're testing, whatever the test pressure is. Now the liquid in the manometer will rise until the pressure exerted by the column matches the test pressure. And this is given by the formula P equals delta H, i.e. change in the height, times rho times G, where delta H is the height of the column, change in the height of the column. P is the density of the liquid, as we saw before, and G is acceleration due to gravity. Now, what's great about this is it already has, because this tube is open here, the normalized atmospheric pressure which is pressing down upon it. So what we're able to do is we're able to see from this pressure gauge what the change in the pressure is with already the atmospheric built in. Now, I know a lot of people got confused around car tires that had pressure in or didn't have pressure. Did they include atmospheric or didn't they? We're going to cover all of that. This is a very, very simple way of measuring something whilst already including the atmospheric pressure into your gauge. And indeed a lot of gauges do that, especially ones that measure PSI, because you don't want to have to keep remembering to add on what normalized atmospheric pressure is. Okay, here we go. Let's get into the difference between absolute and guess pressures. So we have P here, which is the absolute pressure, right? Absolute meaning the total or entirety of something. That is equal to the initial pressure, which is the atmospheric pressure that always exists whether we're doing a measurement with whatever gauge it happens to be, plus our PGH, which we've covered before, which we call gauge pressure. So when we look at our manometer here, we already have P0, we already have, as I said earlier, the initial pressure or the atmospheric pressure, which is built in. So when we're measuring the pressure over here, this is the gauge pressure plus the atmospheric pressure, able to give us this, which is absolute pressure. Now, if you just want to know what gauge pressure is, that is delta P equal to PGH. So gauge pressure is the amount by which P exceeds the atmospheric pressure, which is P0. Really important point to make. So when we're measuring on our car tyre that it's 20 psi, that's 20 psi gauge pressure, which of course you'd have to add on the standing atmospheric pressure of 14 psi, which would actually be in that example 34 psi. This is a really important point to make, really key slide here to explain the differences. So gauge pressure. Pressure gauges like tyre gauges, the example I've just given, measure the difference between the atmospheric pressure and the internal pressure of the tyre or balloon or whatever the test is. Remember, gauge pressure, PG, pressure of gauge, is always equal to the pressure that we're measuring minus the atmospheric pressure. So we always have to remember to include atmospheric pressure, depending what we're measuring, of course. Now let's look at a couple of ways of doing this. Here is a really good example. We have atmospheric pressure here at the top. We have the scale reading of our little tyre gauge. We've got a little spring here to push against the pressure, and then we've got the pressure coming in from the tyre, which might be, in my example, 20 psi. Of course, atmospheric pressure here already built in and being resisted. Now we're moving over here to a little bit more interesting area moving on. This is for measuring absolute pressure typically, and this is a Aneroid barometer, and we're going to look a lot more closely about how this is constructed in a sec. So detailed views of barometers and how they work. This is very similar to the one that I've just purchased. It's almost exactly the same actually. You've got this needle here that you can move around, so you can do tests on where you last measured the pressure to. You've got this black needle that shows you what the pressure is measuring, and in this example it would be 742 millimeters of mercury, which of course relates back to the mercury barometer that we saw earlier, though there is no mercury used in this device when it's measuring. And note actually the weather symbols that are on this variation of barometer. They're very, very useful so that we can see if it's a sunny day, we can see if it's likely to rain, because of course the pressure relates very much really to the weather conditions. Here we see a side view of the barometer. I think a cutaway orthographic view, very, very useful to see because we can understand how it works. What have we got? I'll talk you through it. We've got this sort of concertinaed piece of metal with a partial vacuum inside it, so a corrugated metal box. That responds and moves up and down. As it moves up and down, it bears against this spring. But as it bears against the spring, it also moves this pivot, which goes through a gearing mechanism essentially with a chain on it. It's a very tightly coiled spring here that then moves the pointer up and down as the obviously the corrugated metal box moves up and down. And we'll see that in a few more pictures here. Again, this is a sort of side cutaway view, quite nice 3D view. Again, we can see the vacuum chamber moving up and down. We can see the levering and the spring mechanism. By the way, all of these have been treated so that when the actual temperature changes, these don't change very much at all. So they're neutral to temperature changes up to certain measurements, and I'll show you what those are on the one I bought later on. But basically, you can't say, oh, well, it's temperature that's causing this pointer to move. It isn't. They normalise that through the choice of the materials here, where they use brass and tin and various other substances to make sure that they neutralise any effect of temperature. Here we see a very detailed cutaway view of a real-life, Aneroid barometer. The pointer, we can see the corrugated area here. We can see all the springs and the coils and the chains going across, and we can see that it's quite nice and complicated. It's a finely made device and indeed finely calibrated. And finally, we go here to the specification of the barometer that I in fact used in my experiment, because Spurs said that I wouldn't be able to use it because I would be worried about the effects of the temperature that was occurring. And now that's not the case. I have indeed used it, and the one that I bought, it's not a very high-end one, it was relatively cheap, but as you can see here, it can go down to minus 20 degrees C and all the way up to 50 degrees C, and still be measuring pressure. Great experiment for you. We've got a plastic bag, we've got a sweet jar, we have a thermometer that at the moment seems to be reading 25, 26, and we've got a barometer that measures in millimeters of Hg, which is mercury, and also HPAs. And that's a standard barometer showing, it's the black needle by the way, which is 100 and just short of 110, so maybe 108, something like that. But what I'm going to do is I'm going to put them inside this container, and then I'm going to apply pressure. And I don't think we'll see the temperature change, but let's try the experiment and see. Okay, so that's gone in the container now, as you can see. No pressure applied yet, of course. And then we've also placed the thermometer in there. And we can read both of those through the top, as you can see. Okay. Now all I'm going to do is I'm going to apply a pressure to this container using my hand, as follows. And we can see that the pressure goes up and down. Now I'm going to keep that pressure maintained, and we see that the temperature has not actually changed. It's still on 25. And indeed I'm still maintaining that pressure. Now what I'm going to do is I'm going to release that pressure, and we're going to see if the temperature drops at all. Are we ready? Now release the pressure that I've applied, and the temperature hasn't changed one bit. Let's try that again. So I'm using my hand to apply pressure to this container. There we go, I'm pressurizing it. It's quite a bit of pressure I've applied there. I've turned it into a sunny day. And yet we see the temperature's staying exactly the same. Look, see if I can put a bit more pressure on. Oh, I'm really pushing really hard now. I think I might break the container in a sec. And still, the temperature's remaining the same. The pressure's now going to drop off as I release my hand, and we're going to see if the temperature drops off as well. Which, of course, it doesn't. I think that's QED. Thank you very much for watching. I'm just going to recap really what this video has shown and make sure that we summarize the findings. So first off, we've shown that atmospheric pressure exists, and it absolutely can be measured using an Aneroid barometer. You've already seen that in and out of the pressure sweet jar in which we tested it. Second, that gauge pressure is equal to total or absolute pressure minus atmospheric pressure. We showed that earlier on, looking at the various equations and the way that different gauges worked. Thirdly, pressure change can be measured by a volume change within a container. We saw that with the sweet jar, we saw me change the volume, and we saw the corresponding pressure change on the Aneroid barometer. Number 4. In this test, the change in the pressure does not measurably change the temperature. There's an important word there is measurably, but you saw that we changed the pressure up and down, and really we didn't see that particular thermometer move. And finally, a change in the pressure does not need water or air with water to occur. We didn't introduce anything into the sweet jar, nor did we need to. Thank you very much for your time. Thank you very much for watching, and I've been Toady.
Well. Thank you very much, Toady. Are you there?
I am here. Yeah.
Good stuff. We're about 30 seconds in front of the chat, so if you were watching on the live stream, you probably wouldn't have...
I was. So are we live now?
We are indeed, yeah, we are.
All right, but it's going to then go through to the live stream. Okay, it's a little bit confusing for me. Okay.
No worries. Okay, well, thanks very much. 20-minute presentation. We have had a couple of questions, early questions actually. I'll put them to you. They're essentially along the same lines though. LBB Store says, question, do you have any real-world examples of gas pressure gradients being maintained next to a near vacuum without a barrier?
Of course, this is the key question. I was trying to avoid going down this route because we kind of all know, and I think this has played out for a while. But I'll give 3 examples, just for the sake of furthering the conversation some more. Yeah. So, oh dear, I've got to stop doing that, haven't I? My God. Right. If I do it, just tell me I'm doing it. Plasma balls would be plasma balls would be part of it. Either in ball lightning or in one of those torque, containers they got for nuclear fusion. That I think is Grim says is a place where you can definitely see it, and I think you definitely can in ball lightning. I've read something about that before. Second place is under an aeroplane's wing. That is indeed what gives it lift, which is the aerodynamic force that makes a plane basically take off and allows it to fly. you will see that there is a pressure gradient under the wing, which is different, to the pressure around it. And then I guess finally we see pressure gradients, through isobars, isotherms, and all that good stuff within our atmosphere. I know we'll get into, is there a container, and then we could get into the gravity conversation. As I say, that's quite well rehearsed, and I'd probably rather not further discuss that today, just because I don't think it's going to be very constructive or super interesting, really. But there's 3 examples.
Okay, well, question 2, funnily enough, was the question you didn't want to really answer, I'll read it, you don't have to answer it.
Go on.
Level World, Ranty Flat Earth, hi. Could you ask your guest to show gas pressure without a container, and ask him what he is measure gas pressure without any container? I will be grateful, thanks.
Yeah, I mean, of course, this comes from Nathan's housekeeping, and I'm very, very familiar with all of that, let's call it debate, yeah? The purpose of this, actually, I'll just recap what the purpose of specifically the video was, and I'm not trying to swerve the question, but I think it's an important point. Sorry, I did that again, haven't I? One of the problems that I find when you're going through trying to counter a claim that's made by someone who's picking apart the standard established view of something, even if you understand reasonably well parts of the standard established view, is that you have to put quite a lot of theory in there, which sadly I had to do here, and I know people go, well, it's boring. I find myself getting bored by explaining these things, but you do need a base of a model or a theory before you put forward an experiment, because obviously that experiment links into the ideas and the concepts that you're sharing. And so it's quite difficult to know the I don't mean education level, maybe the different levels that the audience will be at. And of course, some people, the minute they see a formula, aren't very interested. I absolutely get that. But I think it is quite hard to balance that. I could just have shown my video, with the pressure going up and down in the container, and there being no change to the temperature, right? And Spurs had made a claim directly, which is, by the way, why I went and bought the barometer. Spurs told me if you change pressure, it changes temperature. The two are exactly the same, and it will get cold inside there, like he did with those cups that were on the backs and so forth. And I'm sure if Spurs was here, we could debate all that, and I'm very happy to, because I've got quite a lot more information about all of those different things. But my general reflection is it's quite tricky when you're trying to, I won't say debunk, but to counter some of these claims that pull apart an established model. You have to give people some of the basis of what you're talking about. And so I hope that showing how barometers worked and how Torcelli actually did it in the first place, and probably I laboured the first part too much in reflection, but I think that's how we can build up a body of things that we can at least refer to in these conversations, and it's probably up to someone else to demonstrate the gas pressure without a container, because gravity is probably not my best area. Yeah, I'm quite a practical person. The other thing that I like, and I know I've gone on a bit, monologuing a bit, but and I know you'll have another question, but the other thing that I really like is what I call citizen science. So I'm all about a little bit of the theory, but also showing something myself, because I'm a practical person and I like to do sort of experiments if I can. Obviously, we don't have all the facilities, but you can do quite a lot at home if you've got a little bit of a shop, a bit of a workshop or whatever, as they might call it in the US. And I like that side of it. So I'm very keen about bringing actual first-hand experience, because otherwise I could just be reciting a bloody physics book like I virtually did there in the first part. And that's probably not super interesting, and you could probably go and read a better physics book than me reciting it. So I'm all about trying to provide some evidence of some sort, and I try to do that in any sort of presentation that I get involved in. Back to you.
Okay, so there's a few comments in chat saying, OMG, the question.
Yeah, I mean, it's not my job to take it on. As I say, I think there's people who are better positioned than me to debate that, who have debated it. We can say that all we like. I've given 3 examples. You can go explore those examples if you want. Me doing the equations, for gravity and the thinness of what the stratosphere happens to be. I'm not going to be able to answer it now on the hop. And as I say, probably other people are better placed. So I'll leave that for another time.
Okay, so we've had a question from Saucy London. This is not an experiment. Where in nature do we observe plastic bottles pushed by hands? Hands are man-made.
So very happy to counter that. So this comes, of course, as we know, from QE. So a couple of comments about that, because I've been wanting to get them out for a while, and this is a really good format to get a couple of comments out. So the first one is that my definition of science, and one that is, and by the way, there's a lot of different definitions of science and the scientific experiment and the scientific method. For me, it would be an observation of some sort, and then you may look in the natural world, you might make observations, you might dissect something, you might indeed do an experiment with something, and you may have a hypothesis and you may have variables, but you can have scientific exploration just through careful observation, right? You do not necessarily need to manipulate, or as Anthony says, it wiggles something. Yep, that is absolutely not necessary. The second part is, and probably more specific to the is it natural or not, that's just a reductive absurdum. It's ludicrous to say that we can only start to try to look at phenomenon that we only always see in the natural world. I've seen it go round in rings on Nathan's show, obviously. I think even Adam Meakin was, Coriolis he was trying to prove, and he came up with, I can't remember, little things falling off a tree or something, yeah. It's, I don't play that way. I'm not interested in QE's definition of science. When I am involved in science, which is occasionally, not that often, but when I am involved in it, I use the more broad and more generally accepted view of what the scientific method is and what we can look at in science. By the way, anything in the natural world, right? Otherwise, it's supernatural. So my definition of anything in the natural world is natural, right? My hands are natural. Plastic is natural. It's maybe not from nature, but it's certainly from the physical world. To me, sorry, that's a non-argument. You can argue it if you like, and then we'll agree to differ. Not that I'm suggesting you are, Ranty, by the way, but I'm just projecting that towards Source D London.
Okay, yeah, I just ask the questions, and essentially you just answer them. I'm not here to tell you one thing or another. I know. So, you can answer it exactly however you want. It's your presentation. So, from Level World, Ranty Flat Earth, please ask him how he is measuring pressure of gas cloud in a vacuum. I know it's not possible in brackets, but obviously he is able to do this.
Okay, sorry, say that one again. It maybe broke up a bit. How am I measuring?
Please ask him how he is measuring pressure of gas cloud in a vacuum. Pressure of gas cloud in a vacuum.
Right, okay. A little bit confused about that. Maybe he could write a little bit more around what he means. I'm not measuring anything in a vacuum. There is no vacuum in the experiment or the observation. It's not really experiment, observation, I'd say, because I didn't collect a lot of data for it, but I did show it on video. So let's call it observation rather than experiment. Experiment's too grand a word for what I did, but the observation that I made, or the test that I made, is not in a vacuum. All I did was put the things into a jar, a sweet jar in fact, made sure it was quite well sealed, and then I applied pressure, i.e. I changed the volume of the sweet jar with my hand. It was air pressure inside until obviously I made the volume smaller, and that increased the pressure. As you saw, the barometer went right up to whatever it was, a sunny day, I think, on the video. And of course, the temperature didn't change while that was happening. And then I released my hand and it released it up. So there's no vacuum involved in here at all. So I'm not measuring anything in a vacuum.
Yeah, I think what I'll do is I'll just play that again. If you just want to pop yourself on mute, I'll actually just play that part again for people to see if they haven't actually had the chance to see that right now. So
brilliant.
Just bear with me.
I'm pressurising it. Quite a bit of pressure I've applied there. Turned it into a sunny day. And yet we see the temperature's staying exactly the same. Look, see if I can put a bit more pressure on. Oh, I'm really pushing really hard now. I think I might break the container in a sec. And still, the temperature's remaining the same. The pressure's now going to drop off as I release my hand, and we're going to see if the temperature drops off as well. Which, of course, it doesn't. I think that's QED. Thank you very much for watching.
Okay, so I've just played that clip again. Okay, so that's your experiment that you did.
As I say, experiment's probably a bit of a grand word. I've been a bit of a tosser really to call it an experiment, but let's say a test or an observation. Yeah, because But we could call it experiment if we want, but I'd prefer test or observation because experiment kind of gives it. I'm not keen on trying to sound pseudoscientific when it's an observation. Yeah. Okay,
we had somebody just reiterifying that plastic isn't natural; it's man-made.
Of course it is. Yeah. So is the barometer, the metal in the barometer, and the plastic in the glass, and yeah.
And so I'm looking for some more questions, but we do have one from Lottie Says. It's a bit of tongue-in-cheek. I'll ask it you anyway, though. Ask him if he genuinely thought a goatee is a premium decision.
Yeah, it's a reasonable question, and I know Lottie likes a goatee because I think his little icon kind of has a funny little guy. I went with this really because at work I always look quite young, unfortunately, in fact probably very young, and so I wasn't really getting promoted, so I agree with the goatee because I thought that was a better decision to wear some facial hair. And, you get stuck with it, don't you, when you make these choices. That's my answer to Lottie.
Okay.
Very quickly, by the way, on the, Spurs at the beginning, you've met Spurs as I haven't. I'm not claiming that is Spurs, which is why I said, we think this character might be Spurs. I was told by some people it was. I needed a picture of someone. I saw the video. It did sound like Spurs, but I'm absolutely not, just to make it clear to everyone, I am absolutely not saying that is Spurs. I've not met Spurs. So just to be very clear, I'm not promoting whether that is Spurs or not. Yeah.
Okay, well, just to be completely sure and set the record straight, that absolutely isn't Spurskimo. I've met him. I spent the afternoon doing
brilliant. So firsthand, which is good.
Yeah, I've seen him firsthand, and I can assure you that is not Spurskimo. So from Level World, this guy's unbelievable. I know that he didn't do that in his experiment. It was just a question. Sorry, okay, that's fine if he doesn't want to answer. Please ask him how he is measuring pressure of gas cloud in a vacuum. That was his question.
All right, so I'm still unsure about this gas cloud. Does he mean in space or something? Again, it would be better if he was a little bit about what he means by measuring a gas cloud in a vacuum. I'm a bit confused. You can measure pressure in a vacuum. There's many videos that you can see where people do that. I don't have a vacuum chamber myself. I'm sure if I did it, I would be using a pressure gauge to measure it. So again, as I say, I'm a little bit unsure about what his question is.
Okay, well, from Trish Bliff, who says, ask him if he can give Trish one example of this in the natural world, just one.
An example of a sweet jar and a change in the barometric pressure? Of course not. Again, I think I've covered the natural world. I know you guys are very wedded to QE's philosophy. That's fine. You guys are absolutely welcome to your opinion. Most of the body of science, of course, doesn't use that reductive method, and nor will I. So, we'll leave it there. It's one of those things where people can agree to differ. And if someone can give me a citation where everything is written down and all of science is using a method that decides that everything has to be in the natural world, and they can give me a definition of what is and what isn't in the natural world, I will be happy to correct myself and then to follow that specific definition, should it exist. I've not come across it, though.
From Chris Cruel, if you aren't measuring the pressure of the air above you, is there air pressure there?
Well, I suppose it's one of those philosophy things, isn't it? Trees falling down in a forest again. I guess if you're not measuring something, you don't have a pressure until it bears against something. That's part of the definition of pressure. So if you're not measuring it, I suppose it doesn't have theoretically pressure. It's like, does the tree fall down in a forest if no one's there to witness it? I would still say that the pressure exists there myself. But again, that's an assumption. If I'm not measuring it, I couldn't be certain about
that. Question. Proof science has a body.
Well, I'm not sure it really does. It has a number of bodies, doesn't it? It has a number of institutions, and it has a number of views and a number of universities, and it's a collection of human endeavour, really. But, I go kind of with the mainstream, of that. We know about citations and quote mining and stuff, and we probably don't want to rehearse all of that. So as I say, I take my definitions from what most of the mainstream definitions tend to be. I think if you reduce science to something that you can only see in certainly natural world, I think we've all seen QE's videos where he says certain things like, archaeology and geology and other things are pseudoscience. So he reduces a lot of the sciences that we naturally recognize within the scientific community, which I think is problematic. And then, of course, if you say you can only look at things that are in the natural world, it'd be great to understand indeed how he can look at his quantum eraser. I mean, his name comes from an experiment that involves, jewel slits, and the measurement thereof. And I guess I would question where those things, exist and are seen in the natural world, because maybe I've never seen them in the natural world. But, I don't want to get in this to and fro about that. It's people are entitled to their opinions. That's absolutely fine. It isn't my opinion, and it's probably not the mainstream opinion.
Okay, so a follow-up question from Trish. She was the lady that asked if you could provide just one example of this actually happening in nature. So this follow-up question is, so that's a no then. And so he is just using maths that's pre-calculated, and he can't explain the equation for P.
I'd love to talk through that. I'd really love to take that one on if that's her question.
Yeah, go ahead.
Because that's a really good question. It's indeed the one I've set to Anthony today, though Trish may or may not have listened to that hangout. So essentially, here's my view, and others will disagree or as they like with it. Why do I think models are useful, right? By the way, models, I mean, that includes maths or formulas. Okay, so that's what a model is for me. It can be other things as well, but for me, I mean maths and formulas in this example. A model is useful because it is useful, right? I don't like a model just because I want a model of something. I want a model because it helps me to do things in the real world. And I'm someone who is very practical and does work a lot in the real world, in our busy industry, right? And so therefore, if I've got something that I can use reliably to help me make predictions about stuff, so I can go and do other things and I can get results with that, that's why I really like a model. So a good example is Trish's, question there about the barometer and saying that it's theoretical. It has been measured by many people. I personally haven't been able to get that much mercury and put it in a tube. I'd love to, but I pretty much take the videos and the evidence I've seen on rote for that. I probably could do the water one if I could find a tube big enough. But the beauty of that equation, P equals rho GH, which I went through obviously in my presentation, is that more than just a theory, we can go make a prediction. And the question that I asked to Anthony that he said he'll go off and have a look at is essentially this. If we're at 1 atmosphere and we're in a standardized, normalized temperature in Paris, and I think Paris is where the SI unit is measured from, which is why I'm saying Paris could be elsewhere. The temperature doesn't really matter here. And we're at 1 atmosphere. And I've got olive oil. And I know that olive oil is 5 grams per centimeter cubed. And I want to know how long, because I'm going to the glass blowers, and I'm going to tell them to blow the glass for the barometer I'm going to make. How long do I need to make that piece of glass? Now, the fact that I know those two facts that I've given about, what the pressure is, and I know what the density of the olive oil is, using the model that I've got that I've shared with you there, I can practically go to the glass blowers and tell them how long to make that bit of glass. Now, if someone has an alternative to that, if Spurs or Anthony or indeed I think Arwen we were talking to earlier as well, can use density, relative density disequilibrium, I think I'm saying that correctly. If I'm not, apologies, they know what I mean, and show me another way of calculating how long the piece of glass is, if there's a better model, I'll adopt it, right? I'm all about the best models winning. At the moment, the model I presented here, or the calculation, if you like, I presented here, can tell me real things about the real world so that I go and order the right length of glass, because otherwise I'm guessing. So Trish, it's not just about things that are theoretical. This is about taking things into the real world and using them practically. Because I think we lose this sometimes, right? All of this stuff gets discussed and it's semantics and it's theoretical, and this is about real world stuff that we can go and do, which is why I'm interested in it.
Okie dokie. Well, I've been watching the chat and there hasn't been a single question. There is kind of one now. There's a follow-up again from Trish. So in conclusion, he can't explain the P equation because it's been given to him. Is the point that Trish is making? Is that true?
No, I mean, of course it's not. I mean, I've explained it very clearly. I did undertake it with mercury when I was about 13 years old in our physics class, because mercury was still allowed to be used in science labs in private schools. So we actually did it. So I did see it done then. I have seen the shark oil tube in the United States, which is a pretty impressive barometer. And of course, I've seen the ones that are in the Science Museum in London. So these haven't been given to me. All right. Another point, very quickly, and it's the one I touched on about physics and how you learn physics. When I was doing my GCSEs, right, we had equations, but we weren't given the equations until we'd done some experiments. And then in the experiments, we were asked to think about what causes and effects could have been there, what could have changed our variables, and so forth. So the whole way that I learned physics from sort of high school onwards, or O level if you're in the UK onwards, GCSE in the UK onwards, was about thinking about the things that we saw, trying to explain them, and then testing them. And then you get involved in the formulas, of course, because maths does come into it. And of course, if you need a model, you need some kind of formula. Otherwise, you don't really have a model. So I think that's unfair to say they were just given to me. They certainly weren't in my case. And that's probably true of a lot of other people involved, in the early sciences. So she can say that as she likes. She's welcome to her opinion. I know Trish is very pro flat Earth and stuff, and that's fine. She's allowed her opinion. But I would like other people who's listening to this to understand that that's not my view.
Okay, well, I'm just going to roll these two questions into one. Okay, so essentially she wants an answer about the value of P. Was it given to you, yes or no? And the next part of that would be, excellent, give me one real-world example of it then.
Well, I think I've just given a couple of real-world examples, but if you wanted to know if you were going to go and make one of these barometers, you could pick a lot of different examples other than barometers, but if you wanted to go and make a barometer and you had a substance, like I say, of olive oil, and you want to know how long the tube is, you're going to need P equals rho G H, and you're going to need to go and calculate that. I notice she's not concentrating on the second bit around manometers and gauge pressure, but that's fine. That also is very practical. You talk to any mechanics or engineers or people working in labs or even just in car shops where you're using pressure, it comes into it a lot. So there is real world there. And as I say, I think I've stated a number of times what P is. I think she hopefully understands that. H is the height, G is the density of the liquid that you're using, and rho is the G is let me start again. P equals rho GH. Rho is the density of the liquid. H is the height of the glass tube that you would need to contain that liquid, and G is the force due to gravity. Sorry, I just mangled that a bit.
Okay, there's a comment in chat that it's not a specific question, but it's something that I've seen a few people say over time. So it's just general, really. So it's nothing to do with the presentation. But how would you answer this? This is a comment from you who says, "Ballers need to talk about flat Earth. It means they can avoid ever addressing any globe problems, and it's all very convenient, isn't it?" What would you say to that?
Yeah, okay. I guess it's away from this particular topic, and I've enjoyed this topic with Spurs, but we'll put that to the side. What do I think about it? I think there are areas. So why do I avoid your particular hot topic, right, which is optics and, let's say, photography, if we want to call it that area, optics and photography, let's call it that. I really tend not to get involved in that, because for me, I see a lot of anomalous data capture, which, by the way, Ranty, is why I was interested the other day about your regular observations from the same point, because for me, that has a lot more validity if I was looking at it, right? If you'd taken, I don't know, the shot from the same place on 50 occasions, whatever, I'm making a number up, but certainly more than once, than just one shot that shows something a little bit unusual, either going over the curve or not, or compression or not, and those things. So the reason I tend to avoid optics and that is because it's probably an area that does need more understanding, and I think some people are maybe looking at that, but maybe not as much as we would like to see. I don't know of other obvious globe problems, but maybe people would suggest some. I've not come across any, but the optics one, I would agree, is an area that probably could do with more investigation. I would certainly give it that.
Okay, so Trish is quite adamant. She just wants an answer. Was the value P given to you?
What does she mean given to me? Okay, so I don't. Have you got any idea, Ranty, what she means by given to me?
Were you told it at school? Were you taught it at school? Was it given to you?
So what we did is we did a lot. I'm trying to think back, right? So I'm slowing myself down because I don't want to just give a snap answer. I'm trying to think back because it's a reasonable question. Then I see what she means. She means, was it given to me, and did I then go and do tests that proved it, or did I do tests to then calculate it? I'm just thinking back. We actually, I think, because it took us a couple of weeks, when we were doing pressure, and specifically barometric pressure, because it made a really big impression on me, because the mercury is such an interesting substance, right, to sort of play with, though we weren't really allowed to touch it much, and there were leather gloves, and anyway, it's a really interesting thing if you see a lot of mercury in one place. I think we did a number of tests on it, but they were probably helped along by the physics teacher to some extent, obviously, towards where we were trying to get to. But no, I think we first of all derived what that atmospheric pressure was. Then I think we saw the formulas, and then we did further calculations with it, obviously, and it got a lot more advanced from there. But no, I think we did derive it from that original experiment, because we had a real problem when we were doing this. To be fair, at my school, they got the students to do a lot of science, right? It was what they call a Nuffield course I did. I don't know if anyone knows what the Nuffield course is. I don't know if it even exists now, but in my time, the Nuffield course was very much based on the students doing a lot of practical experiments. So that's why I probably like experiments and done a lot of them. And I remember we had real trouble when we were putting the sort of meter-long tube into the mercury to not get like an air bubble in it, and that took us a lot of time to get that right. So as far as I can remember, we derived P first of all, and then the formula was sort of more revealed to us. But I'm willing. It was a long time ago. Could have happened either way.
Okay, so I'm not sure if that's really too relevant, really, but I'll ask it anyway. Anyone know how to calibrate a barometer?
Yeah, so I just wonder why. So why do we why is it 1 atmosphere? I think a lot of people maybe are missing the point of what 1 atmosphere is. Well, what is and maybe I've not done my job in the video. What it is a set of scales, really, as a barometer, right? You can think of it like a set of scales. So essentially, what it's doing is it's weighing the pretty substantial amount of air that's above us against a liquid, right? Now, the thing that surprised me in looking into this, and I'd forgotten it, is that a kilogram of dry air, I think it was a meter cubed of dry air, weighs about a kilogram, right? And that's pretty heavy, because you don't think of air as being that, I don't think of air as being that heavy. We think of it as pretty insubstantial stuff. So meter cubed weighing a kilogram was a bit of a shocker. So if you think of that 60 kilometers of air that's above us, right, that's a lot of air on the sort of left-hand side of the scales. And on the right-hand side of the scales, we've obviously got a liquid that's in a tube that's sealed with a vacuum there. We obviously use mercury because it's smaller than water, but Torricelli used water. As I say, he had problems pumping water above 30 odd feet. The guys invited him in Italy to solve their problem. He didn't solve the problem, but he invented the barometer. So you can use water, you can use mercury, and as I say, you can use other unusual liquids, right? In my example, I said olive oil. You could use all sorts of things, but olive oil's, it's another unusual liquid that you could use to weigh that amount of air that's above you. And that's essentially how we calibrate the barometer to 1 atmosphere. Yeah, that's how we get the 14.7 psi that Right the Hand keeps talking about, is because, it relates to our Earth, and we tend to relate things to our Earth and the surface pressure at mean sea level in Paris, in whatever it happens to be. There's an SI definition of it, just because it's practical and it's useful. So, when you calibrate a barometer, by the way, you often do it to the local pressure. So I think you or somebody else, maybe not you, somebody showed these airline pilots who were calibrating their barometers. And indeed, when I got the barometer that I'm using there, I had to calibrate it it was about 2 weeks, and I had to get readings from the nearest weather station, so I knew what the actual barometric pressure was. So yeah, it takes a little bit of time to sort of zero your barometer in. But essentially, we're looking at the change in pressure anyway with the experiment that I did. And we're not, I'm not NASA, and I'm not measuring things that specifically. I'm sure they've got, much better ways, with standard emissions from something to calibrate their barometers. But yeah, it's a vaguely interesting question.
Okay, there was a comment. It was sort of mentioned as a question, but I'm going to phrase it more as a comment and ask you what you think. Do you believe that it's true or false that more people are turning away from mainstream science?
I think it's probably quite a complicated thing. I think there's a lot of distrust at the moment of all things sort of government and mainstream, and so I think there has been a bit of a distrust, obviously specifically within the community. So it's hard to always tell because we're in these communities, and so we see a lot of that distrust. So then we think that it may be more rife. I don't know how general that is, but I think, it wouldn't surprise me if someone showed that there was that general trend, Ranty. There was a slight trend towards that. It definitely wouldn't surprise me. Oh, by the way, I wish it wasn't, of course, but that's nothing to do with it. Yeah.
Okie dokie. Well, questions seem to have dried up for the time being, but you had something to say. You had something to, before we even started. You said you had a few different things to put out there, and I'm not sure what they are.
Yeah, I'll go through them. We covered pretty well most of them, so we can wrap this up quite quickly if we like. So we spoke about models, and I think because I've heard Nathan mention models, and we don't live in a model and that kind of stuff, so I wanted to get a bit of a point around models. So I think we covered that earlier, so I won't repeat that again. Don't want to bore people. I guess, I've changed this is an interesting point, and you'll be somewhat interested in it, because, I became a Patreon to you. I didn't immediately unsubscribe as a Patreon over the Rumpus sort of court case issue, which we can touch on in a sec. I mean, I think there's possibly two sides to it. I think there was some confusion. Certainly Rumpus did take something away. I don't think it was a slam dunk, but I think that you will tighten up your methodology there, right, to improve the court case thing, is probably what I'd say.
Yeah, I mean, well, to be fair, if I'd have been Tony, I wouldn't have tried to enter into a debate with the Rumpus, which is what he did. I would have tried to do it as a court case, and I would have been able to turn his citations inside out and pretty much demonstrate that what he was saying in the real world doesn't actually work, and I could win the argument in a court case setting, which is basically to try and convince the audience or the people that would be judging. So essentially, you only need to get 10 out of 12 people to sort of like get your thing, and that's what he would have had to do. He could have done it so much easier, so much simpler.
I agree with you, because I listened to it all, and I think Anthony probably wasn't on top form. I think he was travelling that day, to be fair to him. Because I've got a fair amount of respect. So
I'll give you an example. Okay, so the Rumpus, the main point of his argument was a kind of, right? If you remember the term, it's a kind of.
Yep.
So there was a lot of back and forth about what this a kind of meant. Now, let me ask you a question. You can answer it and pretend, or you can answer it and not pretend. I don't want to know too much about you, but I'll just run this by there. I'm just going to assume something, right? So I'm going to assume that you're married. So I'm going to say, are you married? And you're going to say, yes, you are. I say, and your wife's married, yeah? Obviously, she's married to you, yeah?
Yep.
So what would happen if you was out and you were out and your wife was there, and somebody came up to you and asked her the same question, and you turned around and said, well, we're kind of married? What would your wife say?
Well, this is about marriage, not forces, but I suspect my wife would get upset about the use of the term kinda.
Kind of married?
Because, well, exactly, that would imply that there was something maybe not quite kosher about it, or it was a sort of marriage, or it was a marriage of convenience, or whatever, even non-marriage at all, maybe.
Indeed. And also, I would have turned it around to the judge, and I'd have said, Judge, are you a judge, or are you a kind of judge? Now, me, being the judge, if I wanted to be a complete arse, I would have said, are you taking the piss? I'm a judge. Don't say I'm a kind of judge. I am a judge, not a kind of judge. And that, to me, those two things, that if he was trying to play it to win like a court case, this is how you'd have got the semantics done with the actual terminology that was used, and you'd be able to break through that, because it was literally just a debate. It was a debate over what kind of meant, and Tony could have used analogies like that to win his point.
I think he could have won that point. I guess my comment on that, Renty, is, and you won't, well, maybe you will like it or not like it, or whatever. I think there is a lot of problems when we try to get into an understanding in semantics, especially where we're talking about quite complicated areas that certainly I'm not an expert on. Yeah, maybe there are some real genuine experts on, but I'm not sure that I've met that many of them real genuine experts. There's lots of knowledgeable people, but real genuine experts maybe who are in these areas. And so I think the language, or the kind of language that is used often by professors, they're trying, they are preaching to often quite, I think, the converted, and they're not using language which they're expecting to be looked at in this context. And so when they say a kind of force, they do mean some probably quite specific things by a kind of force, because it's a force here, it's not a force there, it's this, that, and the other. And I guess for me, that's fine. We can have those kind of debates. And by the way, I think probably Anthony could have won that one, especially if he'd known about the second paragraph, which looks like a slam dunk. Rumpus, who I spoke to, had a long discussion with him about this, actually, by the way, says it doesn't change the substance of what he said in the first bit or whatever. He left it out for a reason, right? Obviously, because I think it would have dug his hole a little bit down, right? I know why he left it out. Whatever he says, he left it out because it would have, oh, look, it says it's not a force. I think there's bits on both sides. I think for those types of debate, if people want to enter into the real court cases, both people need to be on the top of their game, have all the citations shared beforehand, have the time to look through them, because if you're entering into that kind of stricture, we all make mistakes, we're going to make mistakes. And I'm more interested in moving us forward, which, by the way, is why I've changed my view. And I'll get to that, because then I get some feedback from you on that. Sorry, you probably want to still make a point about the other, and then we can move to why I changed my view.
Yeah, I mean, the whole point of the quote-unquote taking someone to court was, basically because I just want people to answer a question. I'm sick and tired of the obfuscation. I'm sick and tired of running around in circles and never getting to a conclusion on a certain point. And I know it's very difficult for a lot of people to just tell the truth. For whatever reason, they avoid it. They're very good at avoiding questions and turning things around. And you would call them master debaters. So I don't really want... I'm happy to do what I'm still doing with the different formats that I've got going. But if you go to the court, just be honest. Just appeal to yourself, your better nature, and honest in the most open way and honest way that you can. And I feel that that's going to be really difficult for a lot of people to do. And in my opinion, it was evidenced with what the Rumpus did. So, but hopefully that will. In time, people will get used to that, and it's just a breath of fresh air for people. To be honest, I'm incredibly honest. People ask me questions. I'm incredibly honest. I don't lie about anything. There's no point in that. It literally just takes you back to square one, and it's something that people can beat you around the head with if they ever find out that you have been lying. But there's no point in it. There's nothing to gain from lying.
So my comment to that, and by the way, I do agree with you on the lying. I try not to lie because it's not, to me, helpful, but I think I said this in the chat before, but I'll say it now because we're having a chat and it's a good time to put this point. I think the kind of people that will go for those court cases almost are exactly, don't want to say the wrong kind of people, but to some extent maybe, because they're people who are interested in the ego and the win, and it's very hard to take ego out of this, right? None of us like to look either a little bit silly or lose or not know something or whatever, right? They're general for human beings. And I think it's very hard sometimes to admit where we have gaps of our knowledge, or like someone's asking me about gas pressure next to a container and the gravity calculations, right? It really isn't my strong area, so I don't really want to take a punt on it. I'm happy to talk about things that I've got first-hand experience or I did practically. I tried to answer Trish, I stopped myself and then tried to answer, because it would have been easy for me to say no, it wasn't given to me, wouldn't it? It would have been so easy. I tried to think back to try and be honest, because it's a reasonable question. I don't think you get any props for that in this game, though. I think, maybe the people who do the best are very good master debaters. That's why I am supportive of your show, Ranty, because I know you are trying to do something different, and I've actually changed my view, right? As Anthony, if he talks to you about our exchange today on the show, and Arwin as well was there, so a couple of things. I came into this because I listened to Anthony, actually brought me into it, and that's why I came up with this Toady Lily name, right? Yep. Okay. Which I deliberately did because he annoyed me so much when I listened to Anthony, right? I came into it, he said he wouldn't debate me on Jose's because of that name. I reflected on that. I'm a reasonable person. I thought, yeah, that's fair enough. If someone had taken the mickey out of my name, I probably wouldn't want to debate them either. So I changed the name. Okay, that's the first thing. It's now Toady UK because Skype forced me to put a surname in, right? So the only reason it's changed from Toady to Toady UK is because of that. Yeah, and I'm keeping the Toady because that's fine. That's not related to anything to do with Anthony.
Okay.
But the Lily part was, it was a push at him, right? I got rid of that a while ago, quite rightly, because he had a reasonable point, yeah? And I'm not in this to annoy people. And I've changed my view a fair bit recently, after talking to Stingray as well, in that I want to try and be as fair as possible. So we had a very good, parts of it were very good on Jose's show today. interchange with Arwin and Anthony where we got somewhere about this gravity disequilibrium. We were talking about these density columns and stuff. It wasn't bad, and we got to sort of reasonably good to and fro, I think. And I was trying to think some people were trying to bend over backwards there, to be fair, and I'd really like to continue, because I think unless we have an exchange of ideas, it's always going to be the mudslinging and the you're an idiot, and then, you know what I mean, just keeps going round and round. And so I'm very supportive of your efforts, do you see what I mean, to try to bring a better form of debate, and I think there are enough people interested in doing that, I hope. I know it's not as entertaining either, right, as the mudslinging and the big matches and that. But I'd be very supportive of us continuing to try to do this, just to see if it works. If it doesn't work, then we can try something else.
Yeah, well, there's all different formats. I mean, this format has to be very structured. It has to be very it's just information, and it's answering questions. It is going to get a little bit boring for people just tuning in. But obviously, that's where the debates. I do the chit chats because I want to kind of liven things up as well. Obviously, right. The debates. If somebody else with a pressure video wants to go against your let's say your experiment that you did,
test observation,
and go through that maybe they'll find a reason as to why it isn't a valid test, and want to pull you up on that, do a presentation against it, and perhaps you two get into a debate about that. So that would be another show down the line, and of course there's the court stuff as well. So and that would be obviously holding toes to the fire kind of thing. You will answer this question. Just search yourself, search your soul. Be honest with yourself. If you can't be honest with yourself, who can you be honest with? So if you're in court and you literally just feel like you just want to, you've got to let go of your preconceived ideas and stop holding on to whatever belief it is that you have, whether it's flat, globe, or it doesn't rather matter, concave, but come into court and just answer a question as honestly as you possibly can. That's all I'm asking. That's the only way we're actually going to make some headway. So, it's going to take a while for people's the way things have been over the past 3 or 4 years. It's going to take time for people to change out of that mode, I think.
I think you're right. Will, yeah.
Might take 6 months, might take a year, but I'm here for the long run. I'm here to hopefully make this a regular show. So with the support of people like you coming on, a Globe Earther onto a Flat Earthers channel, and putting presentations on, that's what I'm after. That's what I need. That's what the community needs. We need discussions like this, and you're not being overtalked. You get a chance to answer in full without being stopped, and that's exactly what I want. Because what you've brought today and how you've answered things, it's literally on your shoulders. You're the guy that's brought the presentation. You're the one that's answered it to the best of your abilities, and everything that you've provided today will be up for scrutiny. And that's why I don't get involved. That's why I take a back seat and I just ask the questions. So so I'm sure there'll be people that will want to leave some comments in the chat after this video's finished rendering and uploading. So if you wanted to check back, and I'm sure that I think Trish was asking quite a few questions in the chat to you, so maybe you two could carry that conversation on in the chat afterwards. Is there anything you want to say before we round up?
No, I'm good. Good use of a bank holiday Monday. It's very hot here in the UK at the moment, or I don't know, it is for me here. I don't know what it's like in your neck of the woods, but mine's absolutely boiling. So just trying to turn the fans on a bit louder so they don't deafen this out, and relax a bit before work tomorrow. But thanks very much for the chance to come on the show, Renty, and in future, if you're doing one of your chats at the weekend or something and you need someone to fill in the panel, very happy to come on and give some opinions.
Excellent.
Thanks so much.
Well, I will be doing a chit chat later on. What time are we now? So it is. It's 11:10, so probably about 11:30. I'll wrap. I'll start a chit chat show. I know Tony's expressed interest in wanting to come on. I'm assuming you've got to be up for work, so it might be a little late for you.
I might be able to do half an hour or something before 12. Yeah, I normally go to bed about 1, so yeah, I could do half an hour. If Tony wants me on, he might want to make a point without me there, but he's spoken to me enough, I think, to know that I'm not. Have a chat to him and see if he wants it. If he wants it, I'm happy to come in for a bit.
Okay. Right, well, I'll wrap this one up and I'll get the next show sorted out, and we'll be going live again in about 20 minutes. So thank you, Toady, for stopping by. Thank you, everybody in the chat, for keeping things, I would say, civil, but it seems like there's been a civil war going on. I'm not going to...
I haven't looked at it. Okay.
I've been watching it go by, but there we go. Everyone that stopped by, thank you very much, and I hope you all tune in again in 20 minutes, and I'll see you all in the next one.
Bye.